12.5, surface area, okay? So the difference between the figures we have already looked at and then these figures is that these are not flat figures. They're three-dimensional, okay? So, right, something like this, okay? It's like, you can see, there we go. It's got a depth to it as well, okay? So, 3 dimensions, okay? They have a length, a width, and a depth, okay? A 3-dimensional figure is considered a geometric solid, okay? Whose points don't all lie in the same plane. So, okay, a geometric solid. They have a length, a width, and a depth, okay? So, a polygon, if you remember, is a closed figure made up of line segments, okay? Then we have something called a polyhedron. It's simply a 3-dimensional figure, okay, that has flat faces that are shaped like polygons. Okay, so an example is something called a prism. And a prism has parallelograms for sides and 2 faces that are parallel and congruent. And remember, congruent means they are the same size and same shape. Okay? The sides of the prism that are parallel and congruent are called the bases, and the sides that are not bases are called lateral faces. Okay? All right. So, if you consider, we name a prism by the shape of its base, okay? So if you consider a rectangular prism, okay, that means it's going to look like a box. So you got its bases are rectangles. Something like this, okay? A triangular prism means its bases are triangles. Something sort of like that, okay? Maybe, yeah, there we go. And a cube. A cube is just a square prism, basically, okay? So, something like this, okay? A cube would be like a dice, okay? All right. The surface area, when we talk about these, is like you were going to wrap a gift, okay? So how much wrapping paper would you use, okay? So surface area, we're going to use an SA, is going to be the sum of the area of all its surfaces. Okay? So to find the surface area, you're going to find the area of each face and then the sum of all of them to get its surface area. And the units are still square units because it still represents area itself. Okay, so you're talking about if you were to cut these prisms open and lay them flat, find the area of each surface. Okay, so in a rectangular prism, these are all rectangles. So you have a front and a back, so that's two that are the same. The two sides this way are the same, and the top and the bottom are the same. So you have six surfaces that are all rectangles. When you look at a triangular prism, so rectangular and a cube are the same, kind of, okay? This is just going to be a square base instead. So it still has six surfaces, the front and back, the two sides, and the top and the bottom, okay? Triangular prism, when you unfold that, the top and the bottom are triangles, so you find the area of the two triangles, and then the three faces are all rectangles, okay? So you find the area of each rectangle and add them together. And then you can also have a cylinder, okay? A cylinder is just circular bases and then the piece around it, okay? So a cylinder, when you unfold it, it's going to be a rectangle and two circles, okay? So the area of the rectangle is length times width, and then the area of a circle is pi times the radius squared. So you just multiply it by 2. With the rectangle, okay, the length of the rectangle is the circumference of the circle. So 2 pi times the radius. And then the height of the cylinder is the width of the rectangle. So times the height plus 2 pi times the radius squared would be how you would find the surface area of a cylinder. Okay? All right. So here is a rectangular prism. And we're going to find the surface area of it. Okay? I did not label them. So we're going to say this is 7, this is 5, and then this is 2. Okay? So to find the surface area, it's 2 times the front, because the front and the back are going to be the same, plus 2 times the area of the sides, because they're going to be the same, and then 2 times the area of the top, because the top and the bottom are going to be the same. So the front is a rectangle, and it has dimensions of 7 and 5, and then the sides are dimensions of 5 and 2, and the top is 7 and 2. So we've got 2 times 35 plus 2 times 10 plus 2 times 14. So that would be 70 plus 20 plus 28. So the surface area of this rectangular prism is 118, and the units were centimeters. Okay, so that's what it would take to cover the entire surface of this rectangular prism. Okay, then if we have a cylinder, okay, so circular base and the diameter is 8 centimeters, and the height of the cylinder is 12 centimeters. Okay? Then the surface area is going to be 2 pi times the radius. So the diameter is 8, the radius is 4, times the height, which is 12, plus 2 pi times 4 squared. So that's 96 pi plus 16 pi. We should get 401.92 square centimeters, or centimeters squared, when we plug those numbers in. Okay? And that's how we find the surface area of figures. What does it take to cover over the entire figure?